Hey guys, welcome back. We now know how to load a dataset in Pig and how to project and manipulate columns as well. The next logical step is to do some meaningful operations with the dataset. So in this lesson, we're going to learn more Pig Latin instructions by solving a problem. Let's take our stocks dataset. We already saw how to calculate the maximum closing price by symbol with the dataset by writing a MapReduce program. It was an easy program, but still we had to write mapper, reducer, driver program to get the result, right? Let's try something similar with Apache Pig and watch how easy it is to do the same. We're going to list the top 10 stock symbols for year 2003 with the highest average volume using Pig. By solving this problem, we will learn some very useful instructions in Pig Latin. In this lesson, we will learn to filter the dataset, group the dataset, aggregation, limit the number of records, and ordering the dataset. We will also see how to run the Pig instructions as a script, and we'll also see how to pass parameters into a Pig script. Okay, let's get started. Let me remind you the problem again. We're going to list the top 10 stock symbols for year 2003 with the highest average volume. All right? So the first step in the process is to load the dataset. This load operator must be very familiar to you from our last lesson. So let me log on to the grunt shell. Copy this load instruction. Paste it. There you go. Now the dataset is loaded and can be referred by the stocks relation. We want to find out the top 10 stock symbols with the highest average volume only for records for the year 2003. So the next thing we want to do is filtering the dataset with records only from 2003. Let's look at the filter operator. It's very simple. We are using the getYear function to get the year from the date column. Let's read the instruction in plain English, right? Filter stocks by year equals 2003. And we are assigning a name to the result set. So filter underscore by underscore year relation will only have records from 2003 from the stocks dataset. Let's run this instruction. Now that we have filtered the dataset to get only records from 2003, let's group the records by symbol so that we can proceed to calculate the average volume by symbol. In SQL, you can do both grouping and aggregation in a single query, like select symbol, average volume from stocks, group by symbol. That would be a simple select query with a group by class. Whereas in Pig, grouping and aggregation is a two-step process. First, you will use a group by operator to group the records based on the grouping column. And then you will use the for each generate operator to project columns and perform aggregation. Let's look at the group by operator first. Here, in this simple instruction, we are saying group the records in relation filter by year by symbol. The resulting group by records can be referred using group by SYM, group by symbol, right? Let's run this group by instruction into our grunt shell. Now we are ready to perform aggregation, but to perform aggregation, you need to understand the structure of group by symbol. So let's use the describe operator on group by symbol to understand the structure. So I'm going to say describe grp group by symbol. So here's the output. For ease of readability, I have formatted the output of the describe command here. The group by symbol has two columns. The first column is named as group with character array as data type, and filter by year is the second column, which in turn has a collection of records. The group column is nothing but the symbol because you're grouping the records by symbol, and filter by year is a collection of records for that particular symbol. I'll go over the structure and nesting of columns in great detail when we talk about complex data types in Pig. Here is a small sample from the group by relation when you dump the relation. As you can see, each record has a symbol which can be referred by group, and the records for that symbol group together, which is referred by filter by year. Now that we have grouped the records by symbol, we are now ready to apply the aggregation function average. Let's look at the for each instruction here. You're saying for each record in group by symbol, generate group, which is nothing but the symbol, and calculate the average volume on the group records, then round the value. Watch carefully how you're referring to the group records and filter by year. If you go back and look at the structure, it will make perfect sense. Since you have to refer to the volume column inside filter by year, you would have to say filter by year dot volume. Now the resulting relation average underscore volume will have the average volume for all symbols for year 2003. Let's run this instruction. Next, using the order operator, we can then order the records by average volume column. Once ordered, limit the records to 10, which will give you the top 10 average volumes for symbol in year 2003. Finally, use the store instruction to store the result in HDFS. The output will be in tab delimited format by default. If you prefer your output to be in comma delimited format, don't forget to use the pig storage function. So you will be saying using pig storage comma. So let's run these two instructions as well into our grunt shell. So now we are ready to store the output into HDFS. As you can see here, we can execute the instruction one by one in the grunt shell. But the grunt shell is used for development where you can interact with pig, but not for production execution when you want to execute a set of instructions together. So we are going to execute all the instruction as a script outside of the grunt shell. Before we see how to execute the script, I would like to give you a tip. When you are filtering records in the pig script, always filter early. The sooner you filter the records, the better, because subsequent instructions will have only few records to deal with. It is also worth to point out that pig will analyze the script and will, in some cases, move the filter instructions up in the position to optimize the execution. But don't always rely on pig to do the automated optimization. Okay, let's see how to execute the script now. It's very simple. Copy all the instructions into a file and save this file. And to execute this file, simply say pig and give the file location. It's always good practice to include comments in your pig script so that everyone in your team can know what you're trying to do. And regarding the naming convention, you don't have to name the script as .pig, but it's always a common and a best practice to do so. I've already saved the instructions in average-volume.pig file. The location of all the files that I'm looking at here is listed in the lesson description. Let's now execute the script into our cluster. Let me come out of the grunt shell, quit, clear. So to execute the script, simply say pig and give the location of the pig script. Hit enter. Pig will now analyze the instructions, apply any optimizations if possible, prepare an execution plan, and translate your instructions into one or more MapReduce jobs, and will execute the needed MapReduce jobs in your Hadoop cluster. As you can see, pig is running the set of MapReduce jobs right now for your pig script. You can also monitor the status of the execution using the application URL. Here is a pig script that we just executed, average-volume.pig. And just like any MapReduce job, you can basically look at the details of this execution. As you can see, this pig script executed 4 mappers and 1 reducer, and it completed successfully. We can also look at the status here. As you can see, the pig script successfully read about 7,461,000 records and stored 10 records into the output. So now, let's see, Hadoop FSLS and query the output location, which is output pig average volume. And there you go, you see the file from the reducer, part-r with a bunch of zeros as prefix. So copy that, actually copy the whole location, Hadoop fscat. And there you go, here's the output, your top 10 records with highest average volume for year 2003. Now coming back to our pig script, In this script, we have hard-coded the input and the output location. But later, what if you want to change the input and output location? You have to change the script. And if the script is already running in a production environment, this would lead to a deployment. So how can we avoid that? We can avoid that by using parameters. Take a look at this script. In places of the input and the output location, we are saying $input and $output respectively. Now let's see how to pass the values for the $input and the $output. You can pass the values for input and the output from the command line when you execute the PIC script. So check out this instruction right here. It is very similar to the previous command, but as you can see, you're passing two parameters, one for input and one for output. So as you please, you can change the input and the output values for the PIC script anytime you want. And one more important thing, so listen very carefully, right? Once the PIC script is ready, as a part of the development process, you should always test the script. Instead of running untested PIC script in a Hadoop cluster, you can first run it locally, completely bypassing Hadoop using the dataset in the local file system. So take a look at this command right here. You're using the flag -x local, and this will run the PIC script using the local job runner, and the entire script will run locally. The input and the output location you specify here are not in HDFS, but they are in the local file system. See, you don't have to run the PIC script locally on the entire huge dataset, but run it with a much smaller dataset, which is a decent representative of the bigger dataset. This is a very good way of testing your script to identify any errors early in the development process. As you can see, we are using the same script that we used before, average volumes parameters.pic. But since we are using parameters, it's much easier now. We don't have to change the script to run the script locally. Just simply change the parameters when you pass the input and the output locations. In this case, you'll be passing the locations which are actually in the local file system instead of HDFS. So let's try to execute this PIC script locally. Make sure the input location is in the local file system. Hit enter. And as you can see, PIC script is executing this job using the local job runner. So it is not using the Hadoop cluster. So we learned a lot in this lesson, starting with some very useful PIC Latin instructions to group, filter, aggregate, order, etc. And then we also saw how to run the instructions as PIC script. We also moved away from hard coding the input and output location and passed the input and output locations to the script by using parameters. Finally, we executed the script in local mode so that we can test the script locally before executing the script in the cluster. With that, let's wrap this lesson. See you in the next lesson.